I'm going to start with defining what MLOps is. And so if we talk about MLOps, it stands for machine learning operations, and it's the core functions of a machine learning engineering. And it's focused on streamlining the process of making machine learning models to production, and then maintaining as well as monitoring these models. So it is a collaborative function, often comprising of data scientists, DevOps engineers, and IT specialists. And according to popular research these days, about 85% of data science projects fails, and about 4% of companies succeed in deploying their machine learning models to production. Often, most people develop these, train their models on Jupyter notebooks, and that ends it ends in their computers and GitHub repositories and stuff like that. It never gets to production. So the whole idea here is, how do you take these machine learning projects from the planning stage to the production stage, and why some machine learning projects fail, and how you can avoid some of these common mistakes, and how to also scale these models as they get to production. So basically, that is the concept of my presentation. So what is the use of MLOps? It is a very useful approach for creation and quality of machine learning and AI systems. So you adopting this MLOps approach, data scientists and machine learning engineers are able to collaborate. So it's a big environment, unless of course you are the first data scientist in that company. But as the last presenter was saying, you could find yourself in a very big environment, and once you find yourself in that environment, you see that you find yourself collaborating with others. So you're not going to be like an island all by yourself doing stuff from scratch. And this collaborative environment helps to increase the pace of model development and productionization by implementation of continuous integration and continuous deployment. So that is called CI/CD pipelines, mostly in, it's a DevOps concept. So, so why do we need MLOps? Productionization of machine learning can sometimes be very difficult. So we need that concept of MLOps. And also, machine learning lifecycle consists of many complex components, such as data ingestion, data preparations, model training, model tuning, model deployments, model monitoring. That part, most people skip that part mostly. And how do you explain your models? Is it going to be like a black box model that you cannot explain to your boss? What is it? Can you open that black box and make it a transparent box? So these are some of the things you need to consider when you are building models that you think is going to bring value to the company. It also requires collaboration and hands-off across teams. from data engineering to data science to ML engineering. So that's where the collaboration comes in. You're not going to be working alone. So naturally, it requires stringent operational rigor to keep all these processes synchronizing. So because once you are talking with many teams, you need to be able to sync all these ideas and work in tandem. So MLOps encompasses the experimentation, the iterations, the continuous improvement of this machine learning life cycle. So the whole machine learning is a life cycle. So just like the way you born a child from the early stage to the adult stage. So you need to consider that life cycle. And it's very important, else you will miss so many stuff along the way. So what are the benefits of MLOps? Efficiency, scalability, and risk reduction. So it allows data teams to achieve faster model development. They're able to deliver high quality machine learning models and faster deployment in production. So the pace of deployment, it's also very important. So imagine you are working in Google and they've deployed models into production. Imagine how often you need to redeploy, how fast you need to redeploy. And so the pace, it's very important. That's why you need this streamlining concept so that you can be very efficient. So the concept of scalability, you need to also scale your models to thousands of requests. So imagine you build a model and once people are consuming your endpoints or your REST APIs and you have frequent failures. That is a big deal. So you need to be able to deploy your models on systems that can scale your models. So that is also very important. You don't need failures. You need that scalability. So in that scalability concept, you need a cloud platform to be able to deploy these models. If you want to experiment, you can go with Heroku, as most people do. Those are for experimentation. You don't deploy any serious models to production that's going to serve millions of people on Heroku. So that is out of the equation. So we'll talk about where you can scale some of these models in production. So risk reduction also. Machine learning models also need some regulatory scrutiny and drift check. So we're going to talk about the drift check in future slides. So imagine you are working with a bank and they need to adhere to certain regulatory scrutiny from, let's say, Bank of Ghana. So you need to check that, okay, maybe your features that are going into the model, they are not discriminatory or they are according to Bank of Ghana regulatory checks and things like that. So sometimes you might find yourself in those environments where there's somebody who needs to check this regulatory requirements before your model goes into production. And the other side of it is also the drift check. That is almost like the later part of the model being deployed in production. So the drift check, we'll talk a little bit also about the drift check. So what are some of the components of MLOps? The components are huge, but I'm just going to talk about a few of them, which is starting from, if you look at the diagram, the one with the arrow pointing down. I'm going to start from that side because most data scientists nowadays are familiar with the exploratory data analysis, the data prep, model training, and tuning, and that ends there. Most of the time also, they don't look into the model hyperparameter tuning. There are tools nowadays that you can use for this purpose. So the model review. So at this point, we want to track the model lineage, the model versions, and also manage the model artifacts. So these three things that I've mentioned, the model lineage, you need to track it, the model versions, as well as the model artifact. So imagine you are deploying models. Let's say you have version 1.0.0. And then maybe in the next few days, you have another model version called 1.0.1. And you keep going in that order. You need to be able to have a system that can track all these various versions so that you can roll back. And I say roll back to previous model. Let's say you deployed version 2.0.0. And at some point, you need to roll back to a previous version. And you don't have to delete the previous versions because you feel confident that, okay, your model version 2.0.0, it's the absolute or the big boss. There are cases where that model can fail, and you need to roll back to previous versions that were working, but for some reason you decided to upgrade. So those are the things that you need to keep track of. And there are tools, open source tools like MLflow as well as Kubeflow. These are all tools you can use to track. And there's another one called Weights and Biases and Neptune. We'll get to that point very soon. And also the model inference and serving. So how do you manage the frequency of model refresh? So if you talk about model refresh, meaning that how often you retrain your model, how often? That is $1 million question anyway. Somebody will say, okay, I want to retrain my model every midnight. Somebody will say, oh, every year. Somebody will say, oh, every month I have to retrain my model. So that concept of model refreshes might be specific to specific company, but you need to also consider so many things whilst you are refreshing your model. Because the industry that I work, for instance, I work in fraud modeling. So mostly our refresh concept is every day, because we assume that fraud keep changing. Okay, so these fraudsters keep changing their behavior. Once they get caught on one behavior, then they quickly readapt to a new behavior just to beat the system. So in order to incorporate all these new behaviors into our model, we decided to refresh every midnight. So that is just peculiar to us. Your case might be different. Yours might be every year. So you need to take all these options into consideration. So also you need to test your model. If you have a QA team, that is quality assurance team, you need to give the model to this group of people so that they can test your model, how it's predicting and all that before you decide to go into full live deployment. So you can also use CI/CD tools like repos and orchestrators and things like that to automate the pre-production pipeline. So that is for model inference and serving. And also we want to talk about the model deployment and monitoring. That part is also always missing in most data science jobs. So you need to be able to automate the permissions as well as cluster creation, which is the cloud, and to be able to productionize registered models. You need to enable a REST API model endpoint. So this monitoring phase is also another one. So once your model gets into production, don't go to sleep. You don't have to go to sleep. You say, oh, yeah, my model is live, it's prediction, is good, everything looks good, and then you just go and sleep. You need to put systems in place that can monitor your live, if it's a live model that you've built, or it's a batch model that you've built, you still need to have a monitoring system. And there are so many tools that you can use to monitor these models in production in real time or in offline scenario. And you also need to automate the model retraining. You don't have to. You can use cron tools, Airflows. Airflow is an open source tool to schedule jobs. So you can use some of these tools. You can use Apache NiFi to schedule your retraining jobs, or even your model training jobs. You can use all these open source tools to retrain or train your models in real time, so that you don't have to come to work before you hit a button to retrain or train your model. You can automate it. Once you are even sleeping, the job will just kick in and start training and retraining. So you need to also look into things like this automation of some of the pipelines. So here are so many tools out there these days for machine learning. So if you want to go into this space, if you want to be doing the real stuff, you need to learn so many stuff, because some companies might be using certain tools and some companies might not be using those tools. So as you are searching for jobs, you don't actually know which company is going to hire you. So you have to be broad-minded. You need to learn so many tools. Because at one time, there was this girl that I was interviewing, and she told me, oh, she has some experience. And then I asked her, do you know about BET? And she said, no. So basically, she has to now go back and learn what BET is. So you might be faced with some of these challenges, but once you settle down somewhere, then you actually know which tools you need to use for your daily jobs. But once you are hunting for jobs, be prepared that questions from any angle can come to you, because every company and their specific tools. So you need to be broad-minded. Don't just limit yourself to specific tools only, else you're not going to get a job. You go to company A, they are looking for certain things. You go to company B, they are also looking for certain things. So you need to be broaden your learning scope. So these are some data science tools like TensorFlow, PyTorch, Keras, Spark, Scikit-learn, Hugging Face for natural language processing. You have H2O, Python, R, Java, Onyx. Mention them. And if you go down, you have Fast AI, PyCaret, Optuna for hyperparameter tuning, Ray for hyperparameter tuning, as well as model deployment, you have the Condes, you have the Kubernetes, you have the Docker, Amazon SageMaker, you have all these tools, Databricks, they are all out there. So somebody will ask, where do I go? How do I start? You just need to have a plan. So that is the strategy. Just have a plan. Because remember, all these tools are out there. But remember, you cannot know all these tools, but the question is, you don't know where you're going to find yourself. That is the problem. And if you look at this ecosystem also, you have the Hadoop ecosystem, which is also very huge. Assuming those of you who want to do data engineering, these tools are also available. You know, the Zookeepers, the Pig, the Hybase, the Apache Hive, the Apache Spark, Cassandra, and all these things, they're out there. So you need to watch out for them. Those of you who want to do data engineering. Myself, I don't do data engineering, but I find myself using some of these Hadoop ecosystem tools. So you need to be prepared for some of these things. And I talked about the NiFi and then the Airflow, which is mostly for automation, automating your pipelines like training and retraining. And the Kubeflow also, it's also MLOPs tool that runs on Kubernetes for your pipelines, your machine learning pipelines. You have the Databricks and then the ML flows. You have the Jenkins for your CI/CD pipelines. They are also there. Your Plotly, Dash, and DAX, they are all there for your model visualization if you want to visualize stuff. And then also the RESTful APIs like Fast API Array, they are also there if you want to create endpoints out of your models. They are also there. And also for monitoring, which is also very key, you have the Elasticsearch, you have the Kibana, you have the Logstash, you have the Beats, you have Grafana, Prometheus. All these tools are there to monitor your models in real time. So these are tools that are out there that you can easily explore. We don't have to go deep into some of these things, but just take note of all these tools, how you can make use of them in your model deployments. And so why do you need all this ML engineering? So the aim is not to iterate through the list of all the skills, but it requires that data scientists master some of them or each of them. So the goal of increasing the chances of getting an ML project into production and to make sure that it is not a solution that needs constant maintenance or intervention to keep running. So basically, you don't have to rush your models into production, and once it fails, then you start doing maintenance or patching and all that to the models, and that in that scenario, company is going to be losing revenue. You don't want to be doing anything. You have to. That's why the models have to go through all these various stages, so that once it gets into production, you are 100% or 99% sure that things will be working perfectly. And also the tools that I've just mentioned, you just don't need all the skills, but you just need enough data engineering as a data scientist to be able to cope in that environment. And also, you don't need more project management experience to know how to properly define the scope of your data science work and how you can control the project to solving a problem. You just need also need to go through that project management certification or anything. You just need to use some experience and some knowledge that you've acquired elsewhere. So despite many companies going through they all going in all out on machine learning, the hiring massive teams of highly compensated data scientists, and they are also devoting huge amounts of financial and temporal resources. Some of these projects end up failing at incredible high rates. So you need to take note. Some of these companies don't know what they are doing. They just hire, oh, let's go get a data scientist. Let's go get this. Let's go get this. They end up hiring so many that their projects end up failing. They never get to production and they have to dissolve some of the team and things like that happen. Yeah, because it's a game, you know. Once you don't know what you're looking for as a company, you might end up in some of these traps. And so somebody might be asking, what is the difference between DevOps and MLOps? So if you can see that the two diagrams, you can see they are kind of similar some way. So the MLOps concept is being borrowed from the DevOps concept, because at some point DevOps guys were in charge of this machine learning life cycle. So at some point, the data scientists also coined their own term called MLOps, because they want to take the destiny into their own hands. So they also came out with their infinite loop. So if you know infinity, that is the symbol. It's an infinite loop that never ends. So that is how the machine learning life cycle also is. It's a loop that keeps looping around and never ends. And so MLOps, as I described earlier, it's a DevOps principle in software engineering. DevOps also brings a rapid and continuous iterative approach to shipping applications to production. So MLOps is just borrowing the same concept, but we are just applying it to machine learning. So in both cases, the outcome is higher software quality, faster patching and releases, and higher customer satisfaction. That is why you need all this infinite loop to be able to get efficient and scalable machine learning models to production. Yeah, so these are the core components of a DevOps, guys. So I'm not going to go into all this. It's going to take time. So you can grab the slides and then go through it. And this is also the core components of machine learning engineering, which you can also look at it. It's that same infinite loop, the same principle borrowed from DevOps. So you can look also into this. So now, deployment. How do you deploy models? Somebody might be asking, what is all this deployment? How do I get my models to production? So it's perhaps the most confusing and complex part of any ML project. And it comes at the point long after a powerful, accurate model is built. So at that point, you need to productionize your model. So the path between the model creation and then the serving of the model. So serving is like you putting the model, or you are serving the model, or a waiter at a restaurant serving their food to their customers. So that is what it means by model serving. You are serving the model to the end users. So serving of the predictions to a point that they can be used is nearly as difficult, and its possible implementation nearly as varied, and there are models to serve prediction needs. So basically, if you look at the diagram here, this concept might be specific to your case, but it doesn't have to. But this is just the basic concept of batch prediction. With a batch prediction, you train the model and you store the model artifact somewhere, and then maybe the marketing department gives you a set of data and say, okay, can you make predictions on this set of observations? And then you hit a button or you automate that process to make predictions on those features. And maybe in a month's time, they bring another set of data, so you should make a prediction. So those are batch. It could be daily, it could be weekly or monthly or yearly. So those are batch predictions. So in that case, the model is just sitting there doing nothing until some features comes in for predictions. So that is the concept of batch prediction. And that architecture is very simple, straightforward, not too complicated. So there are cases where you need real-time prediction. So in my organization, for instance, we do real-time prediction, okay? Because because every single day, every single minute, second, we are getting transactional data. Every single second, we are getting transactions. We can have as many as millions of transactions per day in our store. So in that scenario, we need to build that system that can constantly make predictions on these transactions that are coming in. So with that architecture, you can see that it's going to be a bit complicated, because every single second you need to make prediction. So you can't go and use Heroku to deploy a model and expect it to scale to millions of transactions per day. I'm sure their server will even break down and will block you or something like that. So this is the architecture. I don't want to go through it, but I can go through it, but it's going to waste time. So once you have the slides, you can figure out what. But the only thing I'll talk about is the Kafka cluster. So mostly our transactions that are coming to our model goes through a Apache Kafka cluster. So that is what is receiving the shocks. Because imagine you are having data coming to your database every second. Imagine what is going to happen to your database. So we use Apache Kafka as the shock. And once we receive all these shocks through the Kafka, then we pass that model through the transaction through our model, and then we have so many different topics. It's a Kafka terminology. I don't want to go there, and we distribute the predictions to wherever it should go and wherever the actual transactional data needs to go. So that is the architecture. No, it is out there, whether batch or real time or near real time scenario that you are deploying for, and then that will give you an idea what kind of tools you need to use for such a deployment scenario. And also, we call something SLA, service level agreement for inference. So that scenario, it asks the question, how quickly does a prediction need to be made? That is the model service level agreement. So in my organization, for instance, our SLA is around 500 milliseconds. So we want to always go below 500 milliseconds. anything above that, we assume that there's going to be a delay. So we want predictions to happen as quickly as possible, not even 1 second, milliseconds. So the more you are considering milliseconds, the more money you are going to spend, because you need a big infrastructure to be able to handle scenarios like that. So if your prediction takes, every hour or every 4 hours, that is when I need to make prediction, that means your cost of making prediction is going to reduce. So you're going to pay less money or the infrastructure that you are going to choose will cost you less money than infrastructure that is going to take 50 milliseconds or 500 milliseconds to make prediction. So take all these things into considerations when you are making such decisions. And also retraining. I mentioned about how often does the model need to be retrained? That is where I said it's $1 million question. That it should be specific to your case. It could be daily, as needed, or every batch run. So you need to take into consideration all these factors depending on your case. You don't have to stick to a particular scenario, but so the retraining phase also is, you can also set certain drift thresholds. Let's say maybe at some point your model predictions were going below certain threshold. Let's say the probability score is getting lower than 50%. So maybe you can create a trigger that, okay, if the predictions are getting lower than 50%, trigger a retrain or redeployment. So you can set all those parameters so that once it hits, then you trigger, it's going to be a potential retrain and redeployment. So you need to put in place those mechanisms that can help you trigger some of these scenarios. Yeah, so I think that is for the frequency, how often you should retrain. And also selecting the training data size. Is it going to be a small training data, or it's going to be a large training data? And the number of models that you need to train, you need to also consider all these things and not selecting the wrong platform to run your machine learning training, and that is going to cost you money. So you need to factor all these scenarios. So if the training size is very small and then you have the number of models that you need to train is just maybe one, you might consider a single virtual machine that you want to use to retrain such a model. And that is going to cost you less money, especially when you are training on a cloud service platform. But if the data set size is large and you have so many models to train, and that needs to be done in a distributed manner, then it means that it's going to cost you more money to handle scenarios like that. And then the inference. So it's also, I think I spoke about that, but I'm just going to hit on that. You need to build a RESTful API endpoint for prediction. So in that scenario, if you are serving in real time, that is going to cost you more money. And you just need to know what you are deploying and how often predictions needs to be made, and you should be fine. But if you are going to that high end, expect that you're going to be paying more money. Especially these days, most people don't have servers in their in their company. Even if you have, how can you even scale to a large scale model? You don't want to be doing that. So it's more even expensive maintaining your own servers these days than in the cloud. So you need to check all this stuff before you go into production. So now let's talk about hyperparameter tuning. So the question is, how do you tune your models? It's very key because you need that optimal parameters that will help you make good predictions. So there are so many tools out there like the Ray, the Optuner, which are used often, the HyperOpt, the Polyazon, the Talos, the Bayesian optimization, the metric optimization engine, the Spearmint, the PyOpt, the Scikit optimizer, and then the SIGOpt. So these are all hyperparameter tuning options that the Talos is also very good. So you need to go in for some of these hyperparameters. So if you are training a deep learning model, for instance, and I ask you, how many epochs do you need to read to train that model? You cannot tell me. So you need some of these algorithms to be able to tell you, okay, you need 100 epochs, or you need 1,000 epochs, or something like that. And then your learning rate also, you need to, it should come from some of these hyperparameter tuning libraries. Okay. So take this hyperparameter tuning very seriously, and it's going to help you in the future. Also, some of the things that people ignore is the monitoring of the feature importance. It's very key. So you need to monitor features that are contributing to the predictions over time. So the feature attribution helps to explain model prediction, the ranking of the features, and all these things. So you need to also take those things into consideration when you are building your model. You need to be able to explain your features. It's very important. As the model also goes into production, you need to have a mechanism to be able to check the features that are being predicted on, as well as checking the distribution of the predictions, so that once it's going below certain threshold, you can trigger certain events. So you need to consider all this. So one tool that you can consider is the SHARP, or the Sharply Additive Explanation. You can check this name on Google. It should give you information around this picture. So you can see in the green, those are the features that are contributing more to the model, and the others are contributing less. So you just need to be able to know how to implement this feature importance. And once you do that, you can throw all the features that are negatively contributing to your model. So it's more or less like a feature selection, but you can still use feature monitoring as part of your machine learning pipelines. Also, you need to justify the model. Okay, so the only thing you can do is to give attribution to your model is to perform A/B testing or multi-arm bandits. That is the champion challenger models. You need to be able to check all these testing so that it can give you an idea which model version is performing very well. So you need a sound statistical models to arrive at some of these decisions so that it can help in lifting revenue. And you need to also show to some extent additional sales that are due to your model. So as and when you deploy your model, how much revenue has the company made out of the model? Are they losing revenue, or they are making revenue, they've started seeing a jump in model revenue. So you need to be able to come up with all these statistical innovations, be able to decide how well your model is contributing to sales. You see, so once the model is not contributing, so it means that you have to abandon the model. You know, you have to shut it down because it's not contributing anything. So you need to do some of this statistical analysis to come up with concrete evidence. It's not like, oh, I think it's not doing well. Oh, no. You don't want to be doing those assumptions. You need to come up with a scientific approach to some of this decision making. So this A/B testing is very similar to canary rollout, which I'm going to talk about in a bit. So you can use traffic splitting to direct subset of users to different model variants for the purpose of comparing and testing different models in live production. So the goal is to see which variants perform better. So with A/B testing, it runs, you need to run this test for weeks to be able to come out with the right decision. So basically you split, if you look at the diagram below, you are splitting. At first, model A is taking 100% traffic. Model B that you just deployed is taking 0% traffic. So if you want to do this A/B testing thing, you need to be able to shift traffic. So most of your traffic will be directed, or 50% will be directed to model A, and then 50% of the traffic will also be directed at model B. And then you'll be able to check which model is actually performing well before you end up shifting the model to the grain deployment. So we call something blue-green deployment. I'll talk about that a little bit. So the model formats. Okay, so the model format is also about serialization. Okay, so how quickly can you retrieve the model width from these serialized model files? So you need to look into options that can serialize to models so that there wouldn't be too much delays in your deployment. So you have to ask the question, which format to export your models to. So some people will talk about pickle. That's what they are mostly used to. Okay. So the other question is, what is my target device? Am I targeting mobile device? Am I doing IoT? Is it web? So you need to ask all these questions. And one emerging area is called TinyML, which is made up of the PyTorch mobile and TensorFlow Lite. So mostly they are for small devices or tiny devices. And the other question is, can I export my PyTorch model to a TensorFlow model? Yes, you can do that. And vice versa, from TensorFlow to PyTorch, can I do that? Yes, you can do that. So there's this open source neural network exchange called Onyx. And it's a standard format for representing machine learning models. So the extension is .ONNX. So it's a format that is being contributed by this huge Microsoft and Google and Amazon. They are all contributing to this open source project. So it's a very fast model format that you can work with. So the legacy format that most people use is the Pojo, the Mojo, the Pickle, which is popular with Python users, the PT, which is for PyTorch, the PB, which is for TensorFlow, and then TensorFlow, and then the HDFI, also TensorFlow. You can use these extensions, the .pmml, the .ml model, the .zip. So all these file extensions are there, but you need to be able to choose which file formats can serialize fast based on your model type. So So just like you have audio and video format like MP3, MP4, somebody will say, okay, why do you use MP3? Or why do you use MP4? Or whatever, MP5 or whatever it is. Though everybody will give certain explanation. Okay, my phone supports MP3 or my phone don't support MP4. Things like that. And we can all tell that the MP3 and the MP4 is an upgraded version. So you can just imagine how fast the video or the audio will be if you're using these advanced formats. So it is the same concept with models. So you need to be able to check out for these model extensions. And also the feature training and the feature engineering. Which format should my training data be in? Is it a CSV? Is it a package? Is it the ORC? Is it a text file? Is it a JSON? Is it Avro? Is it Petastorm? Is it TF records? And then is it .mpy? So we need to check all these file formats, okay, so that you can be able to work with it. Mostly people end up using CSV and things like that, but you should know that there are other formats out there, Parquet and all that, Avro, they're all there. So you can check out some of these things. So if you look at the picture on the right, you can see that all these model formats or frameworks are able to integrate into the Onyx. So which is a very good, even your scikit-learn can integrate into Onyx very well. So you need to check for this file format. And then the model format continues. So if you are working with the Spark, scikit-learn, and TensorFlow, there's another format for you, which is the MLOP. You can consider looking at this one too. Yeah, so I think that is it. So the monitoring of models. So that part is also very huge area. I don't think I have enough time to go into all of them, but I'll just hint. So once the model has been deployed, it needs to be monitored to assure that the ML model performs as expected. Okay, so you need to monitor dependency changes throughout the complete pipeline. You need to monitor data invariants in training and serving inputs, alert if data does not match the schema which was specified in the training loop. You need to check all this in. You need to also monitor whether training and serving features compute the same value. You see, you also need to monitor the numerical stability of the ML models so that you can trigger alerts. So these are some of the things you need to monitor whilst your models is in production. So it's a huge topic. I'm just going to scratch the surface for now. So you can also monitor the computational performance of an ML model system, how much that is measuring the performance of versions and components of the code, the data, all the metric, the CPU, the GPU, all these disk usage, all these things you need to monitor so that it can help you with the cost, okay, the cost of using these cloud platforms. We want to minimize cost. So how stale is the system in production? So you need to also measure the age of the model, okay? So just like we human beings, we always celebrate birthdays. That is the same way you need to measure the age of some of these models whilst they are in production. So older models tend to decay in performance quickly. So that is where the measurement of their age comes in. So you monitor this continuous performance so that it's important to identify the elements for monitoring and create a strategy for the model monitoring before reaching production. So yeah, so you need to measure these models by age. So monitor the process of feature generation as the impact on the real model. Also monitor degradation of the predictive quality of the ML model on served data. So these are actions that you can take. You can measure statistical bias in prediction. if a label is available immediately after the prediction is made, you can measure the quality of prediction in real time and identify problems. So these are all things that you can read out. The slide is going to be shared, so you can go in there and read more about it. And also monitoring tools. What tools do I need to use to monitor my models? As I said before, you have the Elasticsearch, Kibana, Logstash, which is popularly called ELK, EKL. And then you have the Prometheus, then the Grafana. So these are tools to log your model performance so that you can visualize it. In my workplace, like we use the Kibana a lot. So it's able to help us monitor the performance of our models in real time. So I can just go in, open it, and just be monitoring how things are shifting, just like the stock trading market, how you see the graph moving and things like that. You can do some of these things in real time. And also statistical testing, okay? So what statistical tests to use when monitoring models in production? So these are basic ones, the mean max, statistical tests like two sample tests, Kolmogorov, Smirnov, Mann-Whitney, testing for Levine, and categorical features. You want to consider one-way chi-square test, and distribution of your predictions, okay? So as in the time you were training the model, you tested it on some testing data. So what was the distribution? Once the model went into production, you also had some predictions. So what is the distribution of that prediction? So you can use tools like callback, labeler divergence, or people call it KL divergence, to see if the two distributions are the same. You can also use the Jensen-Shannon divergence. How similar is these two probability distribution? You can also consider the Wasserstein distance, which is also popularly called the F movers distance. You can use some of these tools to check how the distribution of the training is compared to the distribution of the prediction. So these are the things you can look into. And also the model decaying. So you can set certain threshold for your model. So if you see the green line, that is the threshold. So you can see that model V1, V2, V3, and V4, October, the threshold was below 50. So you need to trigger a retrain. On December, you can see that the threshold was around 50. You trigger a retrain. The same applies to V3 and V4. So these are things that you can use to retrain your models. Once it goes below certain threshold, you trigger a retraining. And also detecting drift. Okay, this is also very important in the pipeline, machine learning pipeline. So with this feature drift, you need to check if the features that you use to train the model is drifting, or the labels that you use to train the model is also drifting. So these are, and then the prediction, is it also drifting? So these are the things that you need to check. Once things are going or decaying, you can use all these mechanisms to put the model back to the performance as before. So you can read about this drift checking. And also, let's say you have a feature drift. Let's say you have a Fahrenheit data set, okay? The column is Fahrenheit, it's in Fahrenheit. And then this is the distribution of that Fahrenheit. And for some reason, somebody went to converted that Fahrenheit column to, let's say, Celsius. And you didn't know. Maybe the naming was almost the same as before. You didn't know. So once you decide to use that Celsius in your modeling, you can see clearly that things are going to change drastically. So if you convert it to Celsius, you see that this is the distribution. You can see that it's been changed. And before, maybe your model was trained on the Fahrenheit column, but now you didn't know and train on the Celsius. imagine how things are going to. So all the time you need to check that the features are conforming to certain standard or schema. So you need to check all these things before you start building. Not that once they give you the data, then you load it, say pd.read CSV and start jumping and be doing stuff. You need to check all the features well before you do anything. And also the label drift. Okay, so the picture on the left, you can see that as at the time that you were training the model, these are the label probability output. But the picture on the right, as at the time the model went into production, you can see that there's a drift in prediction. So the score is hovering around, let's say 70 to 100. You can see how it's drifting away. But if you look at the probability for distribution for when you actually train the model, you can see that the score somewhere, it was around 20 to 100, 20% to 100%. So you can see how the model is drifting. So you need to check the labels whilst the model is in production. So the prediction also...
Mr. Theophilus, could you wrap up for us?
Okay,
your time
so...
Move on.
Okay, so the prediction drift also can be considered. And then I have so many, let me see how many I have. Okay, so the infrastructure also in deploying your model, you can look at that. And then the model as a service, you can look into this. Model as a dependency, pre-compute serving pattern, that is for mostly forecasting models like weather. You can pre-compute the prediction and store it in a database and later retrieve it as and when needed. And you can also build models on demand. That is the real-time scenario. The federated learning, I don't want to go into that, which is my specialty, but it's something new. I don't want to talk about it for now. And also the model deployment. So how do you deploy these models? They have so many strategies like the recreate, the ramp, the blue-green, canary, A/B testing, and shadow. So there are so many ways you can deploy your model without downtime. So the blue-green deployment, which is very popular these days, is version B of your model is released, and alongside version A, then the traffic is just switched to version B slowly. So basically, you do this in Kubernetes. That is what I'm used to. So you can do all these model deployment strategies using Kubernetes. All right, so I'll stop here, and maybe in the future we can continue with the rest. If there's some time later, I can come in. Anyway.